it's been a weird sort of couple of days. I've been going crazy getting the toddler 2 challenges up and running, and as a result, I was trying to exploit it. Anyways, lost track of time. Had a meeting at the same time where I was. Anyways, I'm here now. Sorry about that. Let me share my screen on Zoom.
This meeting is being recorded.
All right. Okay, here we go. Let's bring up Twitch. Why is it not seeing it live? There we go, live. All right. Shit, we're back. Okay. All right. Awesome stuff. Let's see if anyone's got any questions. What's up? Level 6. Everyone seems to be very interested in level 6. Let's take a look. All right. Here we go. So let's see what the drop off is from level 5 to level 6. Whoa. Level 6 is the hardest one. This seems kind of low. Okay, let's talk about level 6. Apparently the hardest level in this module. I'm going to do the teaching one. You can extrapolate, of course, to the testing one. I'll talk about... wait, so level 6 has actually kept someone from being tied for first. Let's see if we can figure out who it is. Oh, maybe... maybe not. Alright, anyways. Oh, who... Ah, freak mod again over here, rethroned. Cool. Alright. Oh, shit. No one told me my audio was really bad because the microphone is across the room. Here we go. Audio is good. Oh, today's a crazy day. But you know why it's crazy? It's because of Toddler 2. Toddler 2 is insane. Yeah, it's insane. Alright. Let's talk about level 6, finally. All right, we launch it. And then we jump over to the terminal. And we SSH. Not 566. By the way, just a little preview there. It's likely that we're going to have, it should be approved soon, a follow-up course to pwn.college in spring. It's going to be all about finding vulnerabilities and exploiting, and then, of course, responsibly disclosing vulnerabilities in real software. It's going to be pretty interesting. It'll be open to anyone that 100% pwn.college. As in gets their blue belt. All right. So, here we go. Baby race. All right. It needs a path, obviously. So let's give it /flag. Path contains flag. It doesn't like that. So let's, of course, do our typical thing. Let's make a level 6 directory here. And then let's make a symlink to /flag. Boom. It says, oh, file is a symlink. All right. How do we get around the file being a symlink? Right? Level 5, correct me if I'm wrong, should also have the same check. Let me double check. Question on Twitch, is there a 500 level course? It will be a 500 level course. Instructor approval required for everyone to sign up, so let me know if you're interested. And I haven't figured out a way to make it actually world approachable. So for now, tentatively speaking, it's only going to be open to ASU students, at least for that first run for next semester. But it should be a pretty interesting course. I'll share out the syllabus as soon as it's fully approved and online. All right, let me pull up level 5 off camera just to make sure that it has the similar... Actually, let's just launch level 5 to make sure that we have a similar thing. Oh, shit. What the hell? I'm leaking the source code of Baby Shell. That's annoying. No one saw that. Damn. That was OBS going crazy. So now I'm going to kill all GNOME terminal to make sure OBS... Freaking OBS. Alright, GNOME terminals are all gone. Oh, man. There we go. How does that happen? How is software this bad? Okay. All right, level 5. Let's do level 5. Testing 1. Let's just spin it up to convince ourselves that it does the same thing. Right? So, we go to level 5. But in our, okay, here's level 5, and we do ASDF, and it says, okay, file is a symlink. So how did we fix that? We can instead trick it with a directory, right? Here's a directory A with an ASDF file. So A/ASDF is a symlink. And of course, if you say A/ASDF, it's not going to like it. So what we do is we create a directory B. And of course, B/ASDF is perfectly fine. Hold on. Oh. No one can see my screen. All right. No, hold on. Now I'm going through. Okay, that's right. That's right. All right. Let me rewind to level 4, I think. I want to walk you through from first principles, but let me just remind myself of the advancement. Sorry, I was up with toddler 2 until 8 a.m. It was insane. But don't worry, we're going to make it very approachable. It's going to be awesome. Hold on, let me, okay. Okay, never mind. We did a little bit of a... All right. So there's a level missing that we should have had to more smoothly transition this. Level 4 is different. Level 5, of course, requires that this directory, that the file is not a symlink, and it requires that the directory is owned by root. If you actually take a look at level 5 in Binary Ninja, we can see these checks. So what we should have done first is put a file that, put a level that is just checks that the file is a symlink without this root check. But we'll fix that for next year. Okay, so we make sure that there's no flag in the file. There's no way to race condition this. It's just, you know, a check in memory that we don't have any impact over. Then we make sure it's not a symlink. Then we make sure that the directory is owned by user root and group root, and is not writable by other users. And then we just open the file and yeet it to standard output. So when people like me start using the word yeet, you know it's dead. I just killed it. It's over. All right, let's go. So B, even though B/ASDF is not a actually, this is a good ls-lr. It's a recursive ls. So there's directory A and B, and then there's ASDF, which is a link to flag, and then there's BASDF, which is just a file. This isn't good enough because B is not owned by root, right? All right. What is owned by root? Well, a lot of files here are owned by root. etc passwd is owned by root, but actually it's more important about the directory. Directory is owned by root, and other users don't have write access to it. etc is great. Let's do etc. So we can make a link Oops, I have typoed. Make a link to Etsy. Oh my God. Sorry, guys. All right. So, I made a link to slash. Oops. We remove B. Have B. That's a link to Etsy. So now you can look at B pass WD. This is a owned by root. If we actually look at this is not a symlink. This is a normal file. Slash Etsy, of course, is owned by root. So when this program does stat, it is going to be happy that it's owned by root. Now we create a file, a pointer to slash, a symlink to slash flag, and A slash pass WD. So if we cat B slash pass WD, this is the normal pass WD. A slash pass WD. What? Oh, yeah, permission denied because that's pointing to the flag. All right. So what do we do? Now, of course, if we say, hey, give me B slash flag, slash pass WD, it'll happily do it. All right. What did it do? It checked if the directory is on. It checked if the file is named flag. It's not. It checked if the file is a symlink. It's not. It checked if the directory is owned by root, but because it used stat, right? It follows symbolic links, and it actually is looking at slash etc, which is owned by root, and so it's perfectly happy, and it leaks out that file. All right, now I'm going to relaunch this in testing mode, in teaching mode, so that it pauses, so we don't have to stare at this race here. Right now we're talking about level 5. Yeah. So let's run it. All right. Here we go. Let's attack the teaching. All right. So we again have B, that's a pointer symlink to slash etc, and A, and then we have both A slash pass WD, which is a symlink to flag, and B pass WD, which is a normal file. If we run baby race on B slash pass WD, actually let's make this easy. We have a symlink named C that'll go to B. So C slash pass WD right now is pointing to the Etsy pass WD. If we run baby race level 5 on C slash pass WD, it tells us what it's going to do. It tells us it's blocking, right? So okay, it checked lstat on the file. It checked stat on the directory. And now it's happy, and it read it out. All right. So what can we do here? It's waiting, blocking. Boom. It called lstat. It called stat. All right. Now, now we have C, and we basically just change C to point to A instead of B. All right. Now, when this program opens C slash pass WD, That's the flag. But it already checked that the file is not a symlink. Right? Now, boom. Oh. Still needs the directory to be owned by root. Okay, that's not a problem. Oh, hold on. Let's strace this guy and see when it does. Okay, so it did the lstat. It did the stat. Oh, I see. There's a, it prints stat before. Okay, so what we want to win the race after it actually calls stats, so on the second block until input. All right. Of course, it won't be blocking when we actually do this attack. Okay, boom, here. I think this should actually be printed out here. Connor, if you're listening, can you open an issue so we don't forget? Have this printed down here. Okay. Anyway, so it just called stat. Now we change this to point to A. And boom, here's our flag. All right. How do we actually exploit level 5 in practice? Sorry, on the testing. Let me launch level 5 testing. Oh, Connor, you're there. Awesome. While you're opening issues, could you also open an issue for an added level for the directory? The not a symlink concept in the first place. I think we can just make this much smoother in general. All right, so here we are. We are in testing now. Let's go back into our thing here. Of course, the whole thing here is to have sorry, mine went blank for a second. Okay, so we just loop removing the symlink that's there, and then we'll have two other loops that make the symlink to A and make the symlink to B, and then eventually we'll win that race. All right, here we go. Let's see what's going on here. Whoa. There we go. C pointing to B, C pointing to A, and that must be a race condition with LS itself, where by the time LS went to see where C points, it's gone. All right, and now we just do baby race on C/passwd, and if we just do this, Eventually we should win. And if we don't, then we'll have to build a maze. But that part I'll leave as an exercise for the reader. Okay, seriously, what the hell? We're gonna have to build a maze. Do we have time? Yeah, we have time. Do I have a maze built already? Damn. I don't have a maze built. I think it was 800 I decided. It's 600. Okay. The subdirectories. All the way through T. Let's do this. Actually, let's make it all under maze. 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 Okay, let's see. Awesome. Okay, so now we have that. Let's just do. I hate not having my shortcuts. Okay. Okay. Okay, here we go. Nope, too many levels of symbolic links. Yes. Awesome. Okay. Let's do this guy now. Make it a... Awesome. Okay. Perfect. It's still getting swapped in the background over here. Now let's do this maze. No, where is it? So if we build until t, there's a question because there's a limit to the amount of symlinks the system will follow. That's absolutely correct. Yeah. So it's happy with this, but this is 40 basically. T is the 20th letter, and then for each letter we have 2 symlinks, one to the end, one back out. I'm trying to figure out why this is failing to get the file status repeatedly. Let's give it an strace. Oh, it's getting file as a symlink errors. File as a symlink. But this is almost exclusively let's just try one. So it does hit this every once in a while. Okay. Let's just do this for a bit. Maybe this is enough. Oh, let's see. Yes! All we needed was a small maze. Success. There is a depth limit for each. So there's is there a depth limit for each? There's a maximum size of a path in Linux. Someone on Twitch asked if there's a depth limit. And that's 4 kilobytes, 1 page. So that's what I've been assuming is the depth limit of the that's what I've been assuming is the depth limit of each directory depth. But now that I think about it, I'm not so sure that that's that actually is grounded in reality. All right, so that's level 5. Finally, we can move on to level 6. Don't submit this flag. You'll get flagged as a cheater. Yeah. So the question was, can I share the script for 10 seconds? So all we did was do basically the maze to slow down what level 5 does, and then we swapped a symlink C between A and B. B is just a symlink to /etc, so that stat on it works. It shows that it's owned by root. In there, there's the normal etc passwd file, and then we race so that after level 5 verifies that B is owned by root, or that C is owned by root, we switch where C goes so that it becomes points to A. In A, we have a well, now we have a bunch of garbage because our scripts went crazy, but we have a passwd that points to /flag. All right, so someone in Twitch says, but level 6 does not follow symlinks. And you're absolutely correct. So level 6. Let's run level 6 testing 1. All right. Now, when you saw that in level 5 wasn't following symlinks, what did you do? You said, oh, okay, no worries. I can beat it with the directory, right? So that's what we're going to do again. All right, let's reconnect the L here. We're just going to abstract one level higher, and it's going to be awesome. All right, so here we go, level 6, teaching 1. Again, we go B slash, or let's do A pass WD. It says, okay, LStat. On the path, it's a symlink. A slash pass WD is a symlink. So let's do B slash pass WD. Okay. Okay, now the directory is not owned by root. All right. That's fine. We could have run our previous attack, except for we call LStat on the directory, right? The directory now cannot be a symlink. But what directory do we call LStat on? So if you trace it, we call LStat on B, right? Okay. What if there was a directory X and Y? Hold on, I think my AirPods just died. All right, they're back. Let me plug them in, actually, in case they die again. I think I forgot to charge the case. That is no good. Okay. So, if we move A into X, and we move B into Y, and then we... Oh, there's no more B slash pass WD. And then we do X slash B slash pass WD. Oh, sorry. Y slash B slash pass WD. Okay. We call LStat on Y slash B. Y slash B. So the question is, does LStat follow any symlinks? Or does it just, does it only refuse to follow that last symbolic link? Right? Will it follow Y if Y was a symlink? And the answer is yes. So let's have a Z that goes to slash. Sorry. If we do a trace on Z slash etc slash pass WD, it works. Right? And of course, now the challenge is identical. We have Z slash etc slash pass WD. Then, of course, we can have X slash etc slash pass WD, which is the flag. So we have these two paths, one of which is accepted by all of the checks. The other one gets us the flag. And of course, in the background, we do that same link shuffling. And we're golden. Add a maze, and we can win the race. Cool, huh? So the question is, since symlinking directly to the flag won't work, we need to symlink to a directory in root, which goes to the flag. That is not quite it. You need to symlink to a directory in root that will pass all the tests. But then, after you pass the test, you swap out the symlink and get the flag. So let's just do this here, right? So I'm not going to write the whole thing. So, okay. Z goes to slash. This means that we have, let's remove Y because it's no longer relevant. Z has everything that's in, obviously, if you look at Z, you'll end up in slash. So here's our baby race. We can look at etc pass WD, and we can cat etc pass WD. Oops. And the binary is happy to cat etc pass WD. Boom. All right. Now, if we get to that final check, so all of the checks are now good, we swap it out. Let's just okay, so now Z goes to X, and X slash etc slash pass WD, all of this is just directories we created. We created X slash etc. I just did it, right? Like 5 minutes ago. This goes to flag. Now if I do Z slash etc slash pass WD, it points to the flag. I hit enter here. Boom. Here's the flag. So the question is, why does lstat follow the first symlink? It is just how lstat works. Lstat does not follow the last symlink. But it will... it is actually very hard to say in Linux, like, nothing is a symlink. This is plagued with race conditions, right? Because the way that, off the top of my head, maybe I'm not aware of some better way to do it, but basically you just have to go step by step in your path and check if every part is a symlink, right? Of course, normally every single part of that is prone to race conditions. The way that you could do it probably safely without race conditions is by using openat, right? So you start from your current directory, and then you just open at in that directory the next directory and the next directory and so on. And to open, you can pass a no follow flag, so it won't follow the symlinks. And you've seen this before in other challenges. So the question, why does lstat follow the first symlink? lstat only refuses to follow the last symlink. So same with no follow. That's how it works, just in Linux. Right. I wonder if the... Yeah. So lstat not following symlinks isn't the security measure. It's a way for you to get information about symlinks. Cool. What's your question? Okay, so the question is 7 teaching versus 7 testing. Because in 7 teaching, of course, it'll help you win that race. In 7 teaching, it won't. Let me take a quick look at 7. I don't remember exactly what everything is. All right. So, 7 teaching is listening on the network, port 1337. Okay. Asks for so we can make multiple connections to it, right? And we can log in, log out, sudo, flag, and quit. So flag seems interesting. Okay, we have flag, but it says we're not logged in. We log in. All right. Now, of course, teaching will block until input. Let's go sudo. Oops, sudo. Tells us unauthorized. All right, let's look at the binary. We've kind of exhausted what we can look at on the command line. Okay, let's just decompile this guy. All right, let's go to handle connection. Let's go to vuln. All right, sudo. Where's sudo? Sudo is right here. Sudo just tells us unauthorized unless we're root. That's not, and get EID, or sorry, get UID returns the real user ID, if you recall. So we really have to be root. Bummer. There's no way to use sudo. So we're screwed, right? We can't get our privilege level to 2, which is what's required to read the flag. So it would seem that we are. Wait, where's the flag? The flag is right here. Right. Oh, this whole thing is the flag. All right. So if our privilege level is 0, it tells us we're not logged in. If our privilege level is not 1, so if it's 2, for example, it'll give us the flag. But it's not 2. But it doesn't have to be 2. It just has to be not 1 or not 0. What else might it be? Well, obviously, there's a bug somewhere. Otherwise, this 13 people wouldn't have solved it, or however many people solved it. And the bug is right here, where basically if we log out, we will what's it called? Sorry, my mind just went blank. If we log out, we will decrement the privilege level. Wait a second. Connor, we might have noobed this up. No, okay. Phew. All right. So, okay, here it is. Here's the whole logout. Man, this is a confusing command loop. Okay. So yeah. So when we try to log out, it'll check if privilege level is 0. If it is already 0, it won't do anything. But this is a lot of instructions with system calls and everything. Anything could happen here. So obviously there's a race. The race is between starting to log out and checking this privilege level and another thread logging out for you. So then the other thread checks this, passes this check as well, decrements the counter to the privilege level to 0, and then we'll decrement the privilege level to -1. All right, let's just give this a try. run it. Connect. Connect. Log in. No block. Okay, that's fine. Log out. All right. It's about to drop one privilege level, but before it does, we're going to log out here. Boom. Privilege level is 0. Boom. Privilege level is -1. And of course, -1 is neither 0 nor 1. All right. So that's level 7. Now, what is level 8? I'll give you a hint. In the hint, we're just going to do the hint in Binary Ninja. The hint is that this works very differently than level 6 did. Basically, it's not a network server, or than level 7. It's not a network server at all. It just says, hey, welcome. So it's not multi-threaded. We can't get a race condition between the threads. But what is different here? What does this have that the previous level does not? And it's this. We have a signal handler. So go back and look at this lecture, signals and reentrancy. Watch it all the way through. Pay special attention to what happens here. And solve level 8. Yeah, what's up? Right, so the question was, would I recommend doing this on the shell or in Python with pwn tools? I recommend doing it in Python. Although honestly, the shell for this is also fine, right? The real trickiness here is typically when you race these race conditions, right? Especially with multiple threads, you want to end up in a situation where both threads have a lot of data to process before they trigger system calls. Because system calls trigger context switches, and then these context switches give an opportunity for the kernel to go over to executing a different process, right? So you want to, let's say, for example, queue up as much data as possible for each thread to crunch on. So if you were doing what I was doing right then, where basically I was going log in, log out in different, you could just flood 2 or 3 different threads with log in, log out, and then in another thread, just do flag in a loop, for example. But try to give them a lot of data all at once to basically the less that each thread spends waiting on input, the more time that they all spend running concurrently, and the more chance that there is to have a collision. Yeah. Yes, well, okay, so if you're creating netcat process in pwn tools, something doesn't make sense. Pwn tools allows you to make connections, pwn.remote. So you can make 3 connections. But keep in mind that if you create 3 connections or 3 netcat processes, but don't do that, use pwn.remote. If you create those 3, you want to use them in different threads concurrently. You don't want to send data on one, then send data on another, then send data on a third. That won't cause the race condition. To do that, you can use fork. Or different, just separate scripts, honestly. Yeah, so the question is how to use multiple scripts if you're attacking a network service. Usually the way you do it is you just run the process itself on the terminal and then have your scripts just connect with pwn.remote. Yeah, just use pwn remote. How should we use remote here? Well, listen, we're talking about level 7 right now. We rewound. That was a Twitch question. So you just launch. Let me show you. Are we on level 7? Yeah. You launch level 7. Okay, listening to for connections in an IPython session. Here we go. Okay. r.sendLine, log in, and then of course because this is teaching, it'll block, so I have to send the dot to get past that or something. And here privilege level, and so then we can just do boom, and then do it in the same thing in a different script. Boom. Oh, I forgot to log out. Okay, here we go. There we go. There's the race. All right, there's confusing acronyms in the Twitch stream. I'll ignore them. Is there a class size limit for this pwn.college follow-up? Yes. So I'll reiterate. The pwn.college follow-up, it's not messing around. I will not authorize you to take the class unless you have full completion. So right now we'll have, and I have to figure out, non-ASU students probably wouldn't be able to do this, unfortunately. So right now we have 1, 2, 3, 4, 5, 6, 7 people potentially, or I mean, people have gotten 100% pwn.college completion in prior years and so forth. So I don't think there will be a class size, but I think there'll be a natural, very heavy limit. And of course, the reason we are doing 100% is we are going to move fast into real stuff. All right. Twitch question about level 4. We have not yet focused. We had not yet done level 4, so let's take a look. Let's rewind. to level 4. Let's just do teaching so we don't have to do anything hard. Okay. Level 4. Okay, actually, teaching will tell us what's up partially. Let you open a single file. File opened will be read in. It'll verify that it doesn't include flag, is not a symlink, and that the file is not larger than 256 bytes. Cool. So this sounds very promising. Let's take a look at what happens. Opening the file in Binary Ninja. So there's a win function. That's cool. All right. Here we go. We make sure that the file doesn't contain flag. We check to make sure that the file is not a symlink. Then we chill out. And then, along with our else stat here, once we confirm, we get this var 68. Else stat writes a struct over the stack, so this is this. Binary Ninja probably doesn't do this. Do we have structures for else stat? Yes, stat. Awesome. So let's no, what are you doing? Come on. Okay, here we go. So let's change this to a struct stat. Yes. Haha, awesome. It actually worked. It's incredible. But now I can't rename it. Okay. Now it stopped working. All right. Anyways, we'll take what we can get. So we have a stat struct, which else stat fills out for us, and we look at the size. This is the size in bytes, and we check if it's hex 100, so it's less than 256. And if it is less than 256, it'll open that file. And into this buffer, which is hex 198 away from the return address. This is, if we look at the assembly. Oh, shit. Oops. I was saying this doesn't look like assembly. If you look at the assembly, files a symlink, file's too large, boom. Here we go. We call read. RDI comes from ECA. This is the return value of open. Great. So this is the file that we just opened that we confirmed was less than the maximum size. And then this is RBP minus hex 190. But we read an entire page, 4,000 bytes. Obviously, this is an overflow, except for we checked, right? We checked that the size is less than hex 1,000 or hex 100. So on the face of it, there's no overflow here, but obviously there's a race. And this race is exactly here where we block until input. This race is obviously to make a file that passes this check and then redirect a symlink or replace that file with a gigantic file that will cause an overflow here. Once you have an overflow, we can of course, do a check sec. You have no canaries. Home free. Once you have an overflow, pwn it. Remember, there's a win function. And there's no PIE. Cool. All right, there's a question on Twitch. How can I get the private key? You don't need a private key. You just need to upload your public key. If you create an account here, go to settings, go to SSH key, paste it in there. There's a clip of Connor doing it. And then you can start going for it. Cool. All right. Sorry I started late today. It's just a crazy day trying to get Toddler 2 finished up for you all. But it's going to be an awesome module. We're going to have a lot of fun. And we'll see you on Wednesday. Thank you for joining.